end, we're still far from finished. Our next steps are to design an app for caseworkers to input phone numbers and continuously track the device's location, and work with area engineering firms to create custom circuit boards to miniaturize our device as much as possible. If our device saves just one life, it will all be worth it. Hi, I'm Tori Quattlebaum. I'm a senior at Goddard High School. Every year, Samsung asks students across the country to solve a problem in their community using STEM concepts through a competition called Samsung Solve for Tomorrow. Last year, out of thousands of schools that competed, our school was one of 10 chosen to fly to New York City and pitch our idea in the national finals. As national finalists, we won $50,000 in supplies and technology for our school. And amazing as that prize money has been, this after-school project quickly became so much more than a competition. We got to see firsthand that even as teenagers, we can make a positive impact on our community. And we became lifelong problem solvers. The device you saw highlighted in this video was built over the course of 1.5 months, and we could not have made it as far as we did without the skills we've learned in our Project Lead the Way classrooms.
Hi, I'm Hannah Nelson, and I'm a junior at Goddard High School. Each of us up here has had the opportunity to take at least one or more PLTW classes in either middle or high school. In these classes, we learned a variety of content skills necessary to help us complete such a complex problem in such a short amount of time. The design process introduced in many of these classes was a crucial aspect of problem solving. As a team, we had to implement the design process to actually build this device, and for me, a lot of my personal knowledge came from a class I took freshman year called Introduction to Engineering Design. I also had to relearn MIT App Inventor, but I couldn't have done that without the prior knowledge I got from a gateway course I took in middle school called App Creators. I also had to set up the coding for it based on some of the structuring I'd used during my sophomore Project Lead the Way class called Principles of Engineering, where I'd used Vex coding, and I kind of just used that to know how to set up the app. Not only was there the opportunity to learn all these hard skills, we also had to know the essential soft skills necessary to work collaboratively and efficiently.
During my time on the Solve for Tomorrow team, I applied myself in areas that I never would have expected when I began. Originally, I planned to only stay with the prototyping team, but I soon learned that I could bring something to the table in other areas as well. I became known as the B-roll queen by filming all of the background footage used in the final video. I traveled with my team to New York to present our idea, and to Textron Aviation and the Child Advocacy Center of Sedgwick County to get advice on how to improve our device. Before I really got involved with this project and my Project Lead the Way classes, I did not have enough confidence to walk anywhere near a stage or in front of a television camera, let alone speak with conviction about how my team was working to help others in front of a panel of judges and all of our competitors. Going through this competition alongside my PLTW class gave me a sense of independence that I needed to say, I've got this, and believe it. When I presented with my team last year, I stumbled hard. Despite how much I'd practiced and memorized and gone over my part of the speech, I reached the halfway point and all of those words turned to fuzz. At that point, I didn't throw in the towel and walk off the stage. I took a few moments to gather myself and the words I wanted to convey, and I kept going. Learning in a PLTW classroom provided me the tools that I needed to develop confidence in my own abilities and even overcome that failure to speak on stage here. Well, that and the confidence monitor.
Though we might have had the know-how and the willingness it took to build the device, that doesn't mean it was smooth sailing throughout the whole project.
I'm Stephen Kurtzwell. I'm a freshman at Wichita State University in computer engineering.
I'm Connor Rocky. I'm a freshman at Wichita State University in mechanical engineering.
So the first step for the project was choosing the platform to build the device on. Our two main options were Raspberry Pi and Arduino. Now, Pi is basically just a tiny computer. It would be pretty easy to work with, but it would consume more power. Arduino is a bare-bones microcontroller. It's less intuitive, but would consume much less power. So we chose the Arduino because it would be better suited for running off a battery.
Though we had chosen the Arduino, that wasn't communicated to the rest of our team due to how many people were working on the project at the time. This caused us to purchase the parts for a Raspberry Pi-based build rather than the more power-efficient Arduino.
Next, we had to figure out how to use the Arduino once we had it, using the programming language C++. I'd never used C++ before, so I had to use my experience from other programming classes to teach myself the language. In addition, I had to learn the Arduino-specific commands and functions by looking at example code.
The first step for the device was figuring out which technology we were going to use to interface with the Arduino. We decided on a GSM or 2G network module and a GPS module. We chose the GSM because the 4G network would have been too expensive. And to connect these to the Arduino, we used soldering, which was a very difficult process and it required a lot of focus. I failed a lot on this part, but those failures helped me to get better.
Once we had the modules installed and communicating, we couldn't get a GPS signal. So we discovered that our engineering classroom was blocking those signals, which meant many trips down the hall and out the doors to test changes in code. Eventually, we got it set up to receive GPS coordinates, but it would be even longer before we could send those coordinates to another device.
With the GSM module, we needed a SIM card to connect to the cell network. We bought that SIM card from Ting, but the problems with the 2G network did not present themselves, and so we had no more time to fix them. The modules did not have the strength to detect any signals among the high-rises in New York, and New York does not even have a 2G network, which completely crippled our device.
Before New York, we had most modules working in Wichita. The major hurdle there was formatting a text message to include a Google Maps URL. We use string manipulation for this, and a string is just a sequence of characters, but C++ itself has limited built-in support for them. Most of its string functions come from add-ins, which can't be installed on Arduino. So after much research, we found the functions that we could use for a purpose. After that, we sent our first successful text message after about a month of development.
With the code finally working, we set about trying to shrink the device. We utilized a PHONA module, which combines the GPS and GSM into one, and we switched from using leads to using custom wires. We measured the distances between the desired ports on the Arduino, and then cut in strips the wires to our desired lengths.
In the middle of testing, we actually broke a wire off of the battery. We tried to replace that battery with a battery from a local hobby store. The new battery literally smoked the PHONA, which might have been fun and exciting at any other time, but not for us so late in the project. We had to order replacement parts online, which delayed the project, and we couldn't implement more features that we wanted, such as communication with the server to log location data and send it on to an app instead of sending it directly via text message.
As you heard from our lead design engineers, Stephen and Connor, we had quite a few failures throughout our journey. Instead of quitting at the first sign of difficulty, our Project Lead the Way classes taught us that failure is just the first step in a process. The best learning tool for us was trying something, failing, and then trying something else. Most importantly, we took that knowledge and we took it outside of the classroom. Despite the failures and despite the obstacles, we were able to grow as people, and we took that growth and we used it to leave our mark on the world. Thank you.